Hi, Mr. Palmer. Welcome to my science presentation. Today we're going to dive into the world of stoichiometry, which is just a fancy chemistry word for measuring and calculating the amounts of substances in a chemical reaction. Here is my great presentation. So first, I'm going to write the equation on the screen. Here it is. All right, just like that. All right, so first, to do this, we always need to start with the balanced chemical equation. So here is the recipe on my screen. Zinc plus hydric acid reacts to form zinc chloride and hydrogen gas. But right now it isn't balanced, so let's balance this. If we count our atoms, we have one zinc on both sides, which is great, but look at the hydrogen and chlorine. On the left side, we only have one of each. On the right side, we have two hydrogen atoms and two chlorine atoms. So to balance it out, we need to add coefficients, which are the big numbers that go in front of the molecules. So I'm going to place a 2 in front of the HCI, just like this, and we'll write this just below it, just like this. All right. These coefficients tell us the exact recipe. This means that for every one atom of zinc, we need exactly 2 molecules of hydrochloric acid to make our reaction work perfectly. All right, so here we go, Mr. Palmer. This is the very next step. Hopefully you're following me on this. All right, now that our recipe is ready, let's solve a practical conversion problem. All right, let's say we start our experiment with 4.5 moles on zinc. We want to figure out exactly how many moles of hydrogen gas we are going to produce. Okay. To transition from zinc to hydrogen, we have to find the mole ratio. I chose this mole ratio by looking back at the coefficients in our balanced equation. Since there is an invisible 1 right here, right there is a visible 1 in front of the H2, our ratio is simple, just 1 to 1. All right. So now let's set up our conversion using dimensional analysis so we can track our math. We start by writing our given value, 4.5 moles of zinc. So just like this. Yeah, I'm gonna write this down here. Just like so. Next, we multiply it by our fraction bar containing our ratio. So we add this right here. Squeeze that in there. That's a Z, by the way, Mr. Palmer. All right. Just like this. All right, let me think here. All right, now we do the math. I have a calculator here by me, so 4.5 multiplied by 1 divided by 1 gives us 4.5 right here. So now we have to draw a slash line through mole and Zn on top and the bottom. So this just looks like this. Okay. My final answer represents the total amount of hydrogen gas created from our starting zinc. So if we use 4.5 moles on zinc, we'll get exactly 4.5 moles in hydrogen gas. So my final answer is just like this. All right, there it is, 4.5 moles of H2. All right, Mr. Palmer, thank you so much for watching this, and I hope this helps you understand how this works. All right, thank you.